Hi, I'm Balwant Bobili, Specialist Solution Architect at Amazon Web Services. Today I'm going to talk about how you can use a recent launch that is vector search in Amazon ElastiCache or Valkey to deploy semantic caching. And I will highlight the performance benefits and cost savings by leveraging semantic caching. Let me start with the problem statement. Traditional caching works well when queries are identical, that is, they can only match exact keywords or IDs. But with LLMs and semantic search, users often ask different questions that mean the same thing. Regular caching won't catch that. With semantic caching, you can reuse previous generated AI responses by using vector based matching to find similarities between current and prior prompts. If a user prompt is semantically similar to prior prompt, let's say in this case, like user 1 is asking what is capital of France and the user 2 is asking which city is the capital of France, we know their meaning is same, but the text is different. So therefore, they mean the same. So a cached response will be returned instead of making a new LLM inference call. Therefore, a semantic cache reduces the cost of generative AI applications and provide faster responses that improve the user experience. Now let's move on to see how you can deploy semantic caching using ElastiCache for Valkey. For a second, let's say there are no green lines and ElastiCache for Valkey. What happens as part of the traditional request? So client sends the request starting from the left. If you see, client sends the request and it goes to LLM. So I have used in the demo architecture Bedrock Knowledge Base. So Bedrock Knowledge Base provides a generative AI responses with the data that you store in the data sources like S3. So in this case, for this demo, let's say we store the data in S3 and we are using Bedrock knowledge base for retrieving the data using foundational model, that is Anthropic Claude 3.7. So that's the typical request. Now, what happens if we add a semantic caching layer? That is the green lines. So when a user request comes in, instead of directly going to the LLM call, that is Bedrock knowledge base in this case, it actually checks in the ElastiCache or Valkey, and it just not doesn't do like a traditional request, but it actually you'll be able to create vector search indexes as part of like ElastiCache or Valkey 8.2, where you'll be able to once you are able to create those indexes, you'll be able to run like vector searches. Once client sends the request is converted into vector embeddings. And this vector embeddings, for this demo, I'm using Amazon Bedrock Titan embeddings, but you can use Amazon SageMaker, Anthropic, or OpenAI. So once the embeddings are generated, you will be able to use vector search against ElastiCache for Valkey and see if there are similar questions that were asked before to get a response to the client. Let's say if you did not find any response, that's when you go to the Bedrock knowledge base to find the responses. And once you find the response, you respond to the client, and also at the same time you update the cache. So next time a similar prompt comes in, so it can be directly served as from the ElastiCache for Valkey. So that is a cache hit. The overall architecture looks like this. I've developed a sample client, web user interface for sending the queries. And once the queries are sent, it hits the API gateway, and that sends the request to Lambda, where the core logic is stored. It finds if it finds it goes and searches the ElastiCache or Valkey. If it did not find, it goes and gets the data from a knowledge base and also updates the cache, which I'm gonna demo the entire thing shortly. And also I'm gonna show you like how you can create the vector indexes in ElastiCache or Valkey. Before going into demo, let's understand why use ElastiCache for Valkey for semantic caching. So ElastiCache for Valkey is able to handle billions of embeddings with response latency as low as of microseconds and recall up to 99%. The inline real-time index updates provided by vector search for ElastiCache help ensure that the cache updates continuously as user prompts and LLM response flow in. The real-time indexing is crucial to maintain freshness of cache results and cache hit rates, particularly for spiky traffic, and ElastiCache is able to handle this at scale. Now let's move on to the demo. I've already deployed the necessary infrastructure as I was showing in the semantic caching demo. And this the UI you see is the sample web UI that I built for sending the client request. And I already loaded the headset related data in my knowledge base. So let's go ahead and start asking the question. Let me ask wireless connections. Okay, and see what it responds with. Okay, it did go to my knowledge base, and it used Cloud 3.7 on it, and the overall time it took like 5 seconds, and it did get me the response about different wireless connections. Let me run the same question again. This time it actually went for Valky cache and got me the response in single digit milliseconds. Okay, but this is simple caching, right? Let's ask a semantically similar question and see how it behaves. Let me change wireless instead of and put Bluetooth connections. Oh, as you see, it got the response from ElastiCache Valky, and the response time is 8 milliseconds. Even if we asked a semantically similar question, it actually figured out that they're similar, and it got the response from ElastiCache for Valky. And you see the performance difference is much difference when compared to getting it from ElastiCache versus directly fetching it from a knowledge base. And I did publish this entire stack into GitHub, so you can test it out for the same use case, or if you have any different use case, you can absolutely test it out. And I also put some score threshold. You can play with this. The lower the score, the stricter the matching. The higher the score, the broader the matching. Having said that, let's pivot and pivot to GitHub and see how you can set up the project. So this is my base page, and so you clone the project and you make some changes in the config.py as per your requirement. And if you would like to change your dataset, you can absolutely change that. Then you do a Terraform apply that will deploy all the infrastructure. Then you run setup application that will start ingesting into your Bedrock knowledge base, and then you can be able to bring up the interface which I was showing you to send the client requests. And let me also walk you through the index part. So this is the command it ran to create the index. You give the index name, you choose what type of data types. Right now Ash or JSON data types are supported, and you give which column you're storing the embeddings. You choose whether you want to store like HNSW or flat search, and HNSW is highly recommended for large data sets. And dimensions, you can go all the way to 32,000, and there are different distance metrics. There is cosine support, there is L2 support, there is inner product. For my use case, cosine is more efficient, so that's why I've used cosine. Now moving on to the last section of the video, that is cost savings. For simplicity, I'm gonna just compare the cost of foundational model versus ElastiCache. I have run some sample requests and taken the average input token, average output token, and I've sum it up and come up with the cost of foundational model, that is 0.007327 per foundational model request. Now I've come up with 3 scenarios, that is low, medium, high, running like 500 queries, 1000 queries, and 5000 queries, and with a different cache hit ratio. Without cache and with cache. For the cache one, I used cache.r7g.large to highlight the cache savings per hour is $25 for 5000 requests per hour, and elevating the same to monthly. Coming with 3 scenarios, there are different savings. The highest one, like I scenario, is $18,000. I've put links regarding Semantic Cache demo, which I deployed into GitHub, and also a blog which talks about horizontal scaling and performance related metrics with the vector search. And also I put like a getting started link with ElastiCache Valky, and introducing vector search to the Valky if you're using Valky. Open source that is completely compatible with the ElastiCache Valky vector search model. And this is a QR code. If you'd like to start checking the ElastiCache user documentation, you can scan this code. Enjoy testing, and thank you so much.